This is the screencast for parallel and perpendicular lines from graph. In this lesson, you should be able to identify lines as parallel, perpendicular, or neither based on their slopes. Before watching this screencast, it would be a good idea if you were very familiar with calculating slope. And then after this lesson, you should be able to write equations of parallel and perpendicular lines. So, what are parallel lines? One definition is that parallel lines are lines that have equal slopes, or the same slope, but different y-intercepts. Something to note is that all vertical lines are parallel. And visually, when we are looking at lines, the lines do not and will not intersect. Perpendicular lines, there are two definitions. One refers to their slopes, that when you find the product of their slopes, the product will be -1. But a step before that might be comparing slopes, and perpendicular lines will have opposite reciprocal slopes. So one will be positive, one will be negative, and the fractions would be flipped. One thing to note is that all vertical lines and horizontal lines are perpendicular. And visually, when these lines do intersect, they will intersect at a right angle. So even though the lines might be tilted, we would know for sure if these are perpendicular, that would mean that that angle, actually all four angles, would be a right angle. Equal lines are also known as identical lines or the same line. They're lines with the same slope and the same y-intercept. Visually, it would look like one line. So we have our purple line and we have our pink line. Those would be considered equal lines. When graphed, it looks like one line. We also have a description of what happens when lines randomly intersect, not in a special case. Those are called skew. Sometimes they're neither or none of the above. And that just means that they're not parallel, they're not perpendicular, and they're not equal. So they would just be randomly intersecting. So the question is, for line A and B, are they parallel, perpendicular, or neither? So our plan would be to find the slope of each line and then compare those slopes. I do not want to rely visually that that looks like a right angle. So for line A, I'm going to find the slope pretty much by counting boxes. So our rise, that was 6. Our run was 2. And when we simplify, we get a slope of 3. So if these lines are perpendicular, I will be expecting that the slope of line B would be an opposite reciprocal, or -1/3. So let's see what the slope is of line B. So again, rise over run. Now, in this case, I do have a negative slope, so I would be calling that rise a -3, and the run would be 10. So actually, our slope is -3/10. These are actually not perpendicular. Like I said, I was expecting a slope of -1/3, or in this case, a line that's perpendicular would have a slope of +10/3. So in this case, the lines are neither parallel nor perpendicular. So let's take a look at an example of when there is no grid or nor coordinate plane to work from. And what I'm going to do, again, is still find the slope of each line and then compare the slopes. But I'm going to use the calculate slope formula. So for the first line, that passes through to -1 and 5, -7. I will just, substitute my values appropriately. I will get -6/3, which is not a simplified form. So we would simplify our slope to -2. Through the next line, through 0, 0, and -1, 2, I would plug my numbers in appropriately. And then again, this is technically not a simplified answer. So when I simplify, I would get -2. Always compare your slopes completely simplified. And as we can see, both of these slopes are both equal to -2, so therefore the lines are parallel. So those were two examples that could help us identify lines as parallel, perpendicular, or neither based on their slopes.